Welcome learners to the next lecture on artificial intelligence and machine learning in biomedical instrumentation and sensors. This lecture will explore how AI and ML are revolutionizing the field of biomedical instrumentation and sensors, leading to improved healthcare outcomes and groundbreaking research. By the end of this lesson, you will be able to identify the key concepts and applications of artificial intelligence and machine learning in biomedical instrumentation and sensor, describe the role of AI and ML in improving healthcare outcomes and biomedical research, list the major challenges and ethical consideration associated with AI and ML in biomedical instrumentation and sensor. Now, let us begin with what is an AI. Artificial intelligence refers to the simulation of human intelligence processes by computer system. It involves creating algorithms and systems that enable computers to perform tasks that typically requires human intelligence, such as understanding natural language, recognizing pattern, making decisions and learning from experience. AI aims to develop machines that can mimic cognitive functions like problem solving, reasoning, learning and perception. AI has diverse application across industries from healthcare and finance to manufacturing and entertainment, with the potential to automate processes, enhance decision making and drive innovation, while ongoing research seeks to further advance its capabilities and achieve higher level of cognitive function. Now, let us see what AI is contributing in healthcare sector. Artificial intelligence has made significant contribution to the field of biomedical instrumentation and sensors. It has enabled the development of advanced tools and technologies that enhance medical diagnosis, treatment and research. Here are some ways AI is being utilized in this context. The first one which we will going to see is medical imaging interpretation. It involves the analysis of images generated through various medical imaging modalities to diagnose and monitor diseases and conditions. These modalities includes X-rays, CT scans, MRI, ultrasound and nuclear medicine. Medical professionals such as radiologists use their expertise to intercept these images, but AI has emerged as an valuable tool to assist and enhance this process. Now, let us discuss detailed explanation of how medical imaging interpretation works and how AI is integrated into the process. The first one will be image acquisition. Medical images are obtained using specialized imaging equipments. For instance, X-ray machines emit radiation that passes through the body, creating images of bones, tissues and organs. CT scanners use X-rays from different angles to produce cross-sectional images. MRI uses strong magnetic field and radio waves to create detailed images of soft tissues. Ultrasound uses sound waves to create images of organs and blood vessels. The next one will be image pre-processing. Before interpretation, raw images might undergo processing to enhance image quality and improve noise. This can involve techniques like image filtering, contrast adjustment and noise reduction. The next will be images are stored in digital formats within picture archiving and communication systems, often known as PACS. These systems allow medical professionals to access and review images from various imaging modalities. Radiologist interpretation. Traditionally, radiologists review these images to identify abnormalities, diagnose diseases and monitor treatment process. They assess these images for structural anomalies, tissue characteristics and potential pathological conditions. The next is AI assisted interpretation. In this, the first one will be image segmentation. AI algorithms can automatically segment images to separate different structures and tissues, making it easier to focus on specific area of interest. Next is feature extraction. AI can extract subtle features and patterns from images that might not be obvious to the human eye. These aids in the detection of early stage diseases or small abnormalities. Next is deep learning. Convolutional neural network and other deep learning models excels in image analysis. They learn from a vast data set of labeled images to recognize specific patterns, improving accuracy over time. Next is pattern recognition. AI models are trained to identify patterns associated with certain conditions. For example, a deep learning model can train to detect lung nodules indicative of lung cancer in CT scan. The next will be CAD, computer aided detection. CAD systems are AI based tools that flag potential abnormalities for further review by radiologists. They do not replace radiologists, but provide a second set of eyes, reducing the chance of missed findings. The next is clinical decision support. AI algorithms can provide radiologists with relevant information from medical literature, aiding in diagnosis and treatment planning. Validation and review. AI algorithms are trained and validated using large data set of medical images with known diagnosis. Their performance is assessed in terms of sensitivity and specificity. Once deployed, AI interpretations are typically reviewed by radiologists to ensure accuracy. The next in this segment is continual learning. AI systems can improve their performance through continual learning. As they analyze more images and receive feedback from radiologists, they can adopt and refine their algorithm, becoming more accurate over time. Let us see its challenges and consideration. The first challenge is data quality and diversity. AI models require diverse and representative data set to generalize well to real world cases. The next is interpretable AI. Ensuring that AI's decisions are explainable is crucial for gaining radiologists' trust and understanding the basis for AI generated diagnosis. The next is ethical and legal consideration. Ensuring patient privacy and obtaining informed consent for AI assisted interpretation are important ethical consideration. Now, we will see the next in this segment, which is known as disease diagnosis and prediction using artificial intelligence. It involves leveraging advanced algorithms and data analysis techniques to identify and forecast the occurrence of medical conditions in individuals. AI technologies have the potential to significantly enhance healthcare by improving diagnostic accuracy, enabling early disease detection and aiding in personalized treatment planning. Here is how AI is applied in disease diagnosis and prediction. The first one is data collection and integration. AI driven diagnosis and prediction start with the collection and integration of diverse patient data, including medical history, laboratory results, generic information, imaging data and lifestyle factor. This comprehensive data set provides a holistic view of the patient's health. The next is feature extraction. AI algorithms identify relevant features or patterns within the data that are associated with specific diseases. These features could be numerical values, categorical data, or complex patterns that might not be immediately discernible to human clinicals. Next is machine learning algorithm. AI employs various machine learning algorithms to learn from the collected data and make predictions. Common algorithm includes first, classification. These algorithms categorize data into predefined classes. For instance, a classification algorithm could differentiate between a healthy and diseased individual based on their data. The next is regression. Regression algorithm predicts numerical values such as estimating the progression of a disease or predicting blood sugar levels. Next, we will see how early disease detection works. AI algorithms can detect subtle changes in data patterns that might indicate the presence of a disease at an early stage. For instance, analyzing change in a patient's blood work over time could identify early signs of deteriorating condition. Next is predictive analytics. AI can predict the likelihood of disease occurrence based on various risk factors. By analyzing data from various patients, the algorithms can forecast the probability of an individual developing a particular condition. The next is personalized treatment recommendation. AI can assist in developing personalized treatment plans by analyzing patient data and comparing it to vast database of treatment outcomes. This aids healthcare professionals in selecting the most effective treatment for individual patients. Next is continuous learning and improvement. AI models can be designed to continually learn from new data and refine their prediction over time. This adaptability ensures that the system remains up to date and effective. Let us see its challenges and consideration. The first is data quality. Accurate diagnosis and prediction requires high quality and diverse data. Data must be free from errors and biases. The next is interpretability. As AI models become more complex, ensuring their decisions are explainable to healthcare professionals is critical for trust and accountability. Ethical consideration. It has the same ethical consideration protecting patient privacy and ensuring informed consent for data usage are essential ethical consideration. Okay. Now, for the next AI feature, we will see how we can discover drug and development artificial intelligence. It has significantly transformed the field of drug recovery and development by accelerating the process of identifying potential drug candidates, optimizing their properties and predicting their interactions within the human body. This has potential to bring new treatments to patients more quickly and effectively. Here's how AI is applied in drug discovery and development. The first one in this is target identification and validation. Biological data analysis. AI analyzes large scale biological data sets to identify potential drug targets such as proteins, enzymes or genes associated with diseases. Next is network analysis. AI identifies interactions between genes and proteins, helping to understand disease pathways and pinpoint targets for intervention. The next is compound screening and design. Virtual screening. AI algorithm predicts the binding affinity of molecules to target proteins, enabling the screening of large compound libraries to identify potential drug candidates. Next, we will see prediction of drug properties. ADMET prediction. AI models predict the absorption, distribution and metabolism, excretion and toxicity of potential drug candidate, helping to assess their safety and efficacy. Next is solubility and bioavailability. AI algorithms predict a compound's solubility and bioavailability, crucial factors for successful drug development. The next we are going to see is generative models. AI generates new molecular structure with desired properties, providing a larger pool of potential drug candidate for optimization. Next is clinical trial optimization, patient selection. AI analyzes patient data to identify suitable candidates for clinical trials, improving trial success rates and reducing cost. Next is trial design. AI assists in designing adaptive clinical trials where trial parameters can be adjusted based on interim results. The next will be repurposive existing drug. Drug repurposing. AI identifies existing drug that could be repurposed for new therapeutic indications based on their molecular properties and known targets. Now, we will see its challenges and considerations. The challenge in this is data quality and quantity. AI driven drug recovery requires large high quality data sets for training and validation. The next is interpretability. As AI models become more complex, understanding their decision making process becomes important for regulatory approval and scientific validation. Next is ethical and regulatory issues. AI driven drug recovery needs to adhere to regulation standard and ethical consideration include data privacy, informed consent and accountability. Now, as we have seen the artificial intelligence, now we will going to discuss about machine learning. Machine learning is a subset of artificial intelligence that focuses on developing algorithms and models that enable computers to learn from data and make predictions or decisions without being explicitly programmed. In essence, machine learning allows computer to learn from examples and experience, improving their performance over time as they process more data. Now, we will see how machine learning is being used in biomedical instrumentation and sensor. In the realm of biomedical instrumentation and sensors, machine learning plays a pivotal role in harnessing the immense amount of data generated by various medical devices. These instruments capture vital physiological signals, medical images and other relevant information that are essential for accurate diagnosis, treatment and patient care. Machine learning techniques are applied to make sense to this data, extract meaningful patterns and provide actionable insights. Here's a more detailed breakdown of how machine learning operates in this domain. For this, we will see data collection and integration. In data collection and integration are the fundamental process in the realm of biomedical instrumentation and sensor, involving the gathering, organizing and merging of various types of data from diverse sources for analysis and interpretation. In the context of healthcare and medical research, these processes play a crucial role in generating insights that aid in diagnosis, treatment and research advancement. Here's a detailed explanation of data collection and integration in this context. The first is data collection. Biomedical instruments and sensors capture a wide range of data from patients, medical devices and experimental setups. These data can encompass physiological signals. Instruments like ECG monitor, EEG machine and pulse oximeter captures physiological signals such as heart rate, brain activity, blood oxygen level and more. Imaging modalities. Medical imaging devices such as X-ray machines, MRI scanners and ultrasound machines produce detailed visual representation for internal structures and organs. Sensor measurement. Wearable device and monitoring equipment record parameters like blood pressure, temperature, glucose level and movement patterns. Next is genetic and molecular data. Biomedical sensors and assays measures genetic information, protein levels and molecular markers relevant to disease and conditions. Next is patient record. Electronic health record store patients' demographic, medical histories, lab results and treatment plans. Next is research studies. Experimental data from clinical trials, genetic studies and medical research contribute to a wealth of information. Now, as we have seen data collection, we will see now how we do data integration. Once collected, these disparate data types need to be combined, organized and made compatible for analysis. Data integration involves several key steps. The first one will be data cleaning. Raw data often contains error, outliers and missing values. Data cleaning involves identifying and correcting these issues to ensure the accuracy and reliability of subsequent analysis. The next is data transformation. Data from different sources might be in different formats and units. Transformation aligns the data, converting it into a standardized format and unit of measurement. Next is normalization. Data normalization ensures that different variables are on the same scale, preventing one variable from dominating the analysis due to its larger range. Now, as we have seen data collection and data integration, we will now see patient monitoring and alerts. The patient monitoring and alerts involves the continuous observation of patients' physiological parameters and health indicators using biomedical instruments and sensors. Coupled with automatic alert systems that notify healthcare providers of any abnormal or clinical changes in a patient condition, this approach is essential for timely intervention and improved patient outcomes, especially in critical care settings. Here's a detailed explanation of patient monitoring and alert. The first one we are going to see is patient monitoring. Patient monitoring utilizes various sensors and instruments to track and record physiological signals and health parameters. These instruments include vital sign monitors. These devices measures and track key vital signs such as heart rate, blood pressure, respiratory rate and body temperature. Next is continuous glucose monitor. Used in diabetic management, these devices measure blood glucose levels continuously, providing insights to fluctuations and trends. The next in this category is pulse oximeter, ECG, EEG, so on and so forth. We will see automated alerts. Automated alert systems are integrated with patient monitoring setup to provide real-time notification to healthcare professionals when abnormal or critical conditions are detected. These alerts are triggered when data values cross predefined threshold or when the pattern deviates from expected norm. Alerts can be communicated through various means including visual alert. Now, we will see in detail the challenges and ethical consideration using AI and ML. The adoption of artificial intelligence and machine learning in various fields including healthcare brings about numerous benefits, but it also raises significant challenges and ethical consideration that need to be carefully addressed. Here are some of the key challenges and ethical considerations associated with using AI. The first challenge is data quality and bias. AI and ML models heavily depends on data quality. If the data is incomplete, inaccurate or biased, it can lead to incomplete prediction and decision. Biased data can perpetuate existing inequalities and disparities in healthcare. The next is interpretability and transparency. Complex AI models like deep learning can be challenging to interpret, making it difficult to understand how decisions are reached. This lack of transparency can affect trust and accountability. We can see overfitting and generalization as a challenge. Also, models can become overly specialized to the training data and may not perform well on new unseen data. Ensuring robust generalization is crucial. Next will be scalability and deployment. Models that perform well in research setting might struggle when deployed in real world healthcare environment due to difference in data distribution and other factors. The next is data privacy and security. Healthcare data is sensitive and ensuring patient privacy and data security is paramount. Unauthorized access or breaches can have severe consequences. Now, we will see some ethical consideration. The first one is fairness and bias, which I have already told you. The next one will be transparency and explainability. Patients and healthcare providers have the right to know how decisions are made. Ensuring AI models are explainable and interpretable helps build trust. In this category, we can also see accountability and oversight, equality and assess, long-term effects and unintended consequences, and there are few more. So, now let us recap what we have covered today. AI and ML, artificial intelligence and machine learning are transforming biomedical instrumentation and sensor. They improve healthcare outcomes through accurate diagnosis, patient monitoring and personalized treatment. Challenges include data privacy, algorithm bias and ethical consideration. Now, as we have learned, let me ask you questions. The first one is, which of the following best describes the role of AI and ML in biomedical instrumentation and sensor? Your options are A. Enhancing patient experience, B. Improving healthcare outcomes, C. Reducing medical cost, D. All of the above. The correct answer will be improving healthcare outcomes. As artificial intelligence and machine learning algorithms can analyze vast amount of biomedical data, leading to more accurate diagnosis, personalized treatment plans and improved patient outcomes. Let me ask you another question. What are some challenges associated with artificial intelligence and machine learning in biomedical instrumentation and sensor? Data privacy, algorithm bias, interpretability, and your last option is all of the above. The correct answer will be all of the above. As artificial intelligence and machine learning implementation in healthcare raises concern about protecting patient data privacy, addressing algorithmic bias and ensuring the interpretability of AI driven decisions. As I hope that you have answered the questions correctly. Now, let us conclude our lecture. In conclusion, the fusion of artificial intelligence and machine learning with biomedical instrumentation and sensor opens new frontiers in healthcare and research. The potential to save lives, enhance patient care and advance medical knowledge is enormous. As future professional, you will play a pivotal role in shaping this existing field. Thank you for your active participation for this lecture. We will meet in our next lecture on telemedicine and its application. Thank you.